Here we go. If you would, please turn to the first page of the packet of the worksheet that I just gave you. If you're looking at the online file, it's on page 2. So the first thing that you need to do for this worksheet as you're doing this is you're going to start by filling in the pie charts. So this first circle at the top, this is for the very top over here. The second one is for this one. The third one is for this one. And the fourth one is for the bottom. Now, when I say the bottom, what I mean is at a height of 0.00000001. So in other words, it is really close to the ground, but it has not hit the ground yet, which means that you can say the height is about 0. So that way your gravitational potential energy can be 0. But it hasn't hit the ground yet, so it's still moving all the way fast. Does that make sense? Okay, so that's what it means by the bottom. It means the instant before it hits the ground. The other thing I want to point out when you're looking at my drawings, if it is a dot like this top one, that means that it's not moving. If it has a big arrow, that means it's going fast. If it has a small arrow, that means it's going slow. Does that make sense? Okay. So right now on these 4, you're going to put what energy or energies are in, like what type of or types of energy are present at each of these 4 different positions, which also correspond with these 4 places in the table. Ready, go. Alrighty, so now you guys have your pie charts done. So now what I would like you to do is I want you to recognize what is your spring potential energy in this problem. 0. Why? So you could say it hasn't hit the ground. You could say there's no springs, whatever you want to call it. The main thing here is that there is no spring potential energy because nothing is getting squished or stretched. So all of these need to be 0. The other thing that I want you to do next then is I want you to calculate your gravitational potential energy for these 3. And remember that gravitational potential energy is mgh, and G is equal to 9.8. Okay, so this little g is 9.8 all the time, every time. M is mass, and h is height. And these you're multiplying together because it's mgh, so if you don't see a symbol in between, it's multiplication. Go ahead and do this column now. Ready, go. All right, here we go. So we have gravitational potential energy now. So to find our GPE, this is your mass. What was my mass? 5. G is 9.8 times my height is 12. All right, and when I multiply that together, I get 588. Oops, equals. Nice. All right, this one, I do the same thing. GPE is equal to my mass, which is 5, times 9.8, because that's G, times the height, which is 10. And so I get a GPE of 490. And at the bottom, it's the same thing again. 5 times 9.8 times 0. What is it? 0. All right. So what do I need to do next? Well, the next thing that I need to do is I need to identify where kinetic energy is 0. Where is kinetic energy 0? The top, middle, or bottom? Top. If you look at your pie charts, your top one should be all gravitational potential. This one should have a little bit of kinetic and mostly gravitational potential. This one could be half and half, or the main thing is that it has more kinetic than that one. And the bottom one should be all kinetic. So this top one, this is 0 because it is not moving. All right, so to get total energy, you just have to add all the energies together. So if I do my kinetic plus my gravitational potential plus my spring, oops, there we go, then that'll equal my total energy. So my total energy in this case is 0 plus what? 588 plus 0. So that means my total energy is 588 joules. All right, now, if that's my total energy here, what is my total energy for this one? The same, because energy cannot be created or destroyed. How about for this one? 588. And the bottom one? 588. Woo! That's not so bad. All right, so here's my thing that I want you to notice now. All right. All right. Alrighty, folks, are you ready? Yep. Okay. So, gentlemen, no. Away. Well, then I'm glad that I don't matter. Awesome. All right, for this row, how do you find total energy? Well, you just add the other two energies together, right? Okay, so for upper middle, you're going to have your kinetic energy that you don't know, plus your gravitational potential energy, which in this case is 490, and that needs to equal your total, which is 588. How do you find kinetic?
Subtract 490 from 588.
Woo! How do you know to subtract instead of to divide?
Because you're supposed to do the opposite.
Yes, because we're doing the opposite. Woo! All right, so kinetic energy is equal to, what number do you get when you do 588 minus 490? 98. All right, so now this then goes right there, 98. All right, let's do another one. For this row. Okay, so again, now it's 200 though, plus my gravitational potential energy that I don't know is equal to my total, which is 588. Good. So subtract 200 from both sides. And I get a gravitational potential energy of 388.
This is new for Kevin.
Cool. My guess is that you're okay with the bottom one. It's 0 plus 0 plus this has to equal 588. What is my kinetic energy at the bottom? Woo! 588. Because 588 plus 0 is 588. Really complicated. Alrighty. So there's two things we still need to find. One, we need to find the height here. And the other is in part E, we need to find our velocity. So I want to show you how to do both of those. If you want to ignore me and do it yourself, great. Just do it silently without playing cards. All right, so I'm going to go ahead and start with finding this height. And I know that gravitational potential energy is the one that's related to height. So I'm going to use GPE is equal to my mass times G times height. And then I'm going to plug in my numbers. So for this row, my GPE is 388. My mass is 5. G is 9.8. And my height is what I'm trying to figure out. So I'm going to multiply 5 times 9.8 together. And I get 49. And then because it's 49 times h, I'm going to divide both sides by 49. And I get a height of 7.92 in meters. So then that's what goes up there in that little tiny box. Part E of this problem asks you for velocity. So to do that, I need to use the type of energy that is related to velocity, which is kinetic energy, which is 1/2 times mass times velocity squared. My advice is this 1/2 times m, we're going to put together first. So when I do this, my kinetic energy is 200. Then it's 1/2. My mass is still 5. Velocity squared. So like I said, I'm going to do this 1/2 part first and multiply these together. So 1/2 times 5 is 2.5. And then I'll keep on going with the rest of this problem. To get rid of the 2.5, I'm going to do the opposite, which is divide. So it's 2.5 times v squared. So I'm going to divide both sides by 2.5. 200 divided by 2.5 is 80. And that means 80 will be equal to v squared. What's the opposite of square? Square root. So that means I need to take the square root of both sides to get rid of the square. And the square root of 80 is 8.94. And there's my answer for part E. I do want you to use the more specific numbers. Please give me 2 decimal points for each of these answers. A lot of times in these problems, your numbers are going to be really similar, so do not round. Give me 2 decimal points. Does that make sense? Like if you said 9, I would be like, really? No, I want 8.94. Does that make sense? So please don't round. Give me those actual precise answers. All right, once you're good with this, go ahead and fill in the rest of the blanks for this problem and then go on to number 2. Ready to go?